Hi, welcome back. In this lecture, we'll take a look into the overview of real-world project. Basically we are going to develop a real-world project to demonstrate the usage of Spring Boot and Apache Kafka. This course is also useful to you if you are using event-driven architecture in your microservices. Let's say you are using Apache Kafka for the communication between multiple microservices as a messaging system. Then you can go ahead and take this course so that you will understand the fundamentals of Apache Kafka and how you can use Apache Kafka in a Spring Boot project. Here is our project goal. Basically we are going to read a huge amount of real-time stream data from the Wikimedia to the database. And if you can see the architecture over here, so we are going to create a Kafka producer which will read a real-time stream data from the Wikimedia, and then it will write that data to the Kafka broker, and then we will create a Kafka consumer which will consume the real-time stream data from the Kafka broker, and then it will write to the database. So this is how the workflow for this project. This real-world project is the best use case to demonstrate the usage of Apache Kafka, because basically we use Apache Kafka to deal with a large amount of data, right? In this real-world project, we are going to see how to create a Kafka producer to read a large amount of real-time stream data from the Wikimedia, and then it will write that data to the Kafka broker, and then we'll see how to write a Kafka consumer to consume that real-time stream data from the Kafka broker, and then it will write to the database. So this is how the architecture for this real-world project. Let's head over to this link and let's see how the real-time stream data looks like. So let me go to the browser and let me hit this link in the browser, and you can able to see this is a large amount of data. So whatever the users do the changes in the Wikimedia, that will be retrieved by using this REST API. If you can closely observe this real-time Wikimedia data, it has the events. So whenever a user make a change in the Wikimedia, that entry will be stored as an event in the Wikimedia server, and by using this REST API we can fetch all the user made recent changes in the Wikimedia. Let me show you a couple of demos for this real-time Wikimedia stream data. So here you can see someone has created this user interface. It behind the scene uses real-time Wikimedia stream data. You can see here the real-time data records are displaying here. So whatever the changes the user made in a Wikimedia, that changes will be reflected over here, and these are the charts, and you can find the real-time data changes in these charts. So another demo example, you can see someone has written the HTML and JavaScript code to create this user interface. This sample demo behind the scene reads real-time Wikimedia stream data, and it will display that data here in a user interface. In this real-time project, we'll see how to use Apache Kafka broker to read the real-time stream data from the Wikimedia and then write to the database. Alright, great. I will see you in the next lecture. Hi, welcome back. In this lecture, we'll take a look into Spring Boot Kafka project setup. Basically we are going to create two projects, and you can think of these projects as a microservices. First we create a Kafka producer Wikimedia. So this project acts as a Kafka producer which will read a real-time Wikimedia stream data, and it will write that data to the Kafka broker. Next we'll create a Kafka consumer database project which will consume or read a real-time stream data from the Kafka broker, and then it will write that data to the database. Alright, this is how at a high level Spring Boot Kafka project setup looks like. Basically we are going to create two projects as a microservices. First one is Kafka producer Wikimedia as a microservice 1, and Kafka consumer database as a microservice 2, and we are going to use Apache Kafka as a messaging system to exchange the messages between microservice 1 and microservice 2. Alright, great. Hi, welcome back. In this lecture, we'll install and set up Apache Kafka locally. It's pretty simple to install and set up Apache Kafka locally. Just follow the steps that I am going to implement in this lecture. Head over to the browser, and in a new tab, just type Apache Kafka download and hit enter. So go ahead and click on this first link, that is download Apache Kafka. So this will navigate to the Apache Kafka downloads page. Here you can see get started tab, and within that here you can see quick start link. So go ahead and click on this quick start link over here. Well, in this course we are going to use Apache Kafka quick start page a lot. Okay, so just scroll down and here you can see the steps. So these are the steps are pretty useful to install and set up the Kafka locally. Well, let's take a look into the step 1. Step 1 is get Kafka. It means we need to download the latest Kafka release locally and then we need to extract it. So go ahead and click on this download link over here. Well, go ahead and click on this link to download Apache Kafka as a tar file locally. Well, I'm going to click on this link. Kafka is downloading in a file system, so it will take a couple of seconds as per the internet speed. Well, once Apache Kafka downloaded as a zip file or a tar file, then go ahead and open in a folder and just go ahead and extract this file. So I'm going to extract it. Now let's go and let's rename to this folder. So I'm going to rename as Kafka. So just remove the version from here. Let's keep Kafka. Alright, now let's see the second step. So let me go back here, and second step is like we need to start the Kafka environment. Well, before starting the Kafka environment, make sure that you have installed Java 8 on your machine. Alright, next we need to start the Zookeeper. Well, you might be wondering what is Zookeeper, right? So here you can see the diagram, Kafka ecosystem diagram over here. So this Kafka ecosystem has a Kafka cluster, and within a Kafka cluster we have 3 Kafka brokers, Kafka broker 1, 2, 3. Alright, and here we have one Zookeeper. So Zookeeper is basically a service that will manage the state of all the Kafka brokers within a Kafka cluster, and it will also manage the configuration of topic and producer and consumer as well. Alright, so just remember we need to start the Zookeeper so that it will start managing the state of Kafka brokers in a Kafka cluster. Well, in our case we have only one Kafka broker that we are going to install locally. So first we need to start the Zookeeper so that it will manage the state of the Kafka broker. Well, in order to start the Zookeeper service, we need to execute this sh file, that is zookeeper-server-start.sh. Well, this sh file is located within a bin folder. If you go to Kafka, just expand the Kafka, and here we have a bin. Within bin folder you can see all these sh files. So these sh files will support for Mac and Linux. If you are using Windows, then make sure that you will use these bat files. Okay, so I am using Mac, so I am going to execute the sh files. Alright, so just search for zookeeper-server-start.sh over here, and there we go. So here you can see zookeeper-server-start.sh. So this is the sh file we are going to run in order to start the Zookeeper service. So just go back to browser and let me copy this command and let me execute in a terminal. So let me copy it and let me open the terminal over here, and let me zoom this terminal and let me paste here. So before executing this command we need to move into Kafka folder, right? So just go ahead and type cd, and then we need to move to the downloads folder, right? Downloads, hit enter, and within downloads folder we have Kafka folder, right? So cd Kafka, and then we need to enter this command. So within Kafka folder we have bin folder, within bin folder we have this sh file, and then config/zookeeper.properties. Well, this sh file will refer all the properties from this properties file. Hit enter, and there we go. You can see Zookeeper service has started. Well, once Zookeeper service has started, then we can go ahead and run the Kafka broker service. Well, just open a new terminal session and run this command. Well, let me copy this command. Well, if you can see this command over here, in order to start the Kafka broker service, we are going to run this sh file, that is kafka-server-start.sh. So this sh file is located within a bin folder. Well, let me go to Kafka again, and within the bin folder you can see a bunch of sh files. So if you are using Windows, then you should use a bat file. Okay, so let me search for Kafka server start.sh file. So this is the sh file that we are going to run in order to start the Kafka broker service. Well, let me go back to the steps. Let me copy this command and let me go to the terminal. So if you are using Windows, then make sure that you use command prompt. Well, let me open the new cell. Okay, so let me zoom it a little bit. So if you are using Windows, then you can go ahead and open new command prompt. So let me go into the downloads folder, cd downloads, cd Kafka. Within downloads folder we have Kafka folder, right? So go to the Kafka folder and then run this command, that is kafka-server-start.sh file, and make sure that you provide this server.properties file. Okay, because this sh file basically refer all the properties from this server-properties file. So let me hit enter. So this will run the Apache Kafka broker service. Well, let me maximize this. Well, Apache Kafka broker service will run on localhost 9092. So let me just search for 9092 port and let me show you the log. It states the Apache broker service has started. Let me search for 9092 and there we go. So this is the log statement. You can able to see recorded new controller. From now on we'll use a broker service localhost 9092, which means our Apache Kafka broker service is started on port 9092. Alright, and this localhost colon 9092 we are going to use in our Spring Boot application in order to interact with the Kafka. Okay, great. Now let me go back to the steps. Once all services has successfully launched, you will have a basic Kafka environment running and ready to use. Well, we have started Zookeeper service as well as Kafka broker service. Now we are good to use a Kafka broker service in our local machine. Well, let me recap what we have done in this lecture. We have downloaded the latest version of Kafka from the official website, and then we have installed in our local machine, and then we have started Zookeeper service as well as Kafka broker service. Now we are good to use a Kafka environment in our Spring Boot application. Hi, welcome back. In this lecture we'll create Spring Boot project for Wikimedia producer. Well, basically we are going to create a multi-module Maven project. Within that we create a sub-module. Alright, so first we'll create a Spring Boot project using Spring Initializer, and then we'll import that project in IntelliJ IDEA, and then we'll create sub-modules within that project. So let's go to browser, and in a new tab just type start.spring.io. This will brings up Spring Initializer. Let's go and let's fill up the project information over here. So here we have two types of project, Maven and Gradle. So let's keep Maven project as selected and choose language Java, and Spring Boot version 2.6.7. so as of now it is 2.6.7, but it may differ in your case. Alright, next let's fill up the project metadata over here. So let me give group as net.java guides, and then artifact something like Spring Boot Kafka real world project, something like this, and this is the description. So name is same as artifact, and description is demo project for Spring Boot and Kafka, and package let's give net.javaguide.springboot. Alright, and packaging let's keep jar. So basically we are going to create a parent Maven parent project, but we need to change the packaging type as a POM, so we'll do it later. As of now let's select packaging as jar, and Java version let's keep 11 as selected. You can choose Java 8, 11, 17, 18 as per the JDK installation on your machine, but let's keep default, that is Java 11 as selected. Next let's go to the dependency section over here, click on add dependencies, and here we are going to choose Kafka dependency for Spring application. So let's type Spring for Kafka, and there we go. So this is the Spring for Apache Kafka dependency, which will provide support to integrate Apache Kafka in a Spring based applications. So let's choose this dependency. Okay, so this dependency is enough for us. So also let's choose the Lombok dependency to reduce the boilerplate code. So let me choose this dependency. Alright, perfect. If you want to explore, you can go ahead and explore this project by using explore option. So you can just go to pom.xml and you can just review whatever the dependency that you have added. Okay, we have added Spring for Kafka dependency as well as Lombok dependency. Okay, just close it and go ahead and click on generate button. So this will generate this Spring Boot project as a zip file. Alright, let's open this zip file in a folder and then let's unzip this file. So let me unzip it. Perfect. Now let's open the IntelliJ IDEA. So I'm going to open the IntelliJ IDEA over here, and here you can see a couple of options: new project, open, get from CVS. So we are going to open the existing project in the IntelliJ IDEA. So let's go ahead and click on open over here, and then let's go to the location where your Spring Boot project is downloaded. So in my case it is downloads folder. So select it and click on open. So this will open up Spring Boot project in the IntelliJ IDEA. Alright, now we have generated Spring Boot application using Spring Initializer and imported that project in the IntelliJ IDEA. Let's make this Spring Boot project as a multi-module Maven project. Okay, so let's go and let's make the necessary changes to make this project as a multi-module Maven project. So first of all, we need to make this project as a parent project, right? So go to the pom.xml and we need to add a packaging tag over here. So just add a packaging tag and let's give a value as pom. Okay, so whenever we create a multi-module Maven project, we have to provide packaging type as a pom for a parent project. Okay, now we are good to create a sub-modules within this parent project. Okay, just save it and just go to this icon here and just load the Maven changes. Okay, now the parent project is ready. Now let's go ahead and let's create a module within this parent project. So right click on this project, new, and then choose module and tick mark this and then click on next and then give module name as Kafka Producer Wikimedia and then click on finish. So this will create a module within this parent project. So you can see as soon as we create a module within this parent project, a pom.xml will be updated. So you can see here, just open the pom.xml of parent project, and if you can see this tag over here, modules section will be added in a pom.xml, and you can see the module. Okay, so just go ahead and click on this icon to load the Maven changes. Okay, now we have created Kafka Producer Wikimedia module within this parent project. Well, if you can observe this module that we have created within this parent project, this module project is not a Spring Boot project. So let's make this module as a Spring Boot project. So let me quickly create a package and let's name it as net.javaguides.springboot, and let's create a Spring Boot main entry point class within this package. Right click, new, and then choose class, and let's give class name as Spring Boot Producer Application. Alright, perfect. And let's annotate this class with @Spring Boot Application annotation, and let's have a main method within this class. Alright, and within a main method, let's call Spring Application and then call static method run method, and then just pass Spring Boot Producer Application dot class. Okay, that's it. Now we have created Spring Boot main entry point class for this module. Okay, so if you can run this Spring Boot project, it should work. There we go. There is no error in a console, right? So what we have done so far, we have created a parent project, and within that parent project we have created a module, and we have made this module as a Spring Boot project. Okay, so in order to verify this Spring Boot project setup, what we can do is we can go to Maven over here, and from here we can just run the command Maven clean install. Okay, and let's see whether the setup is correct or not. And here we go, the Maven build success. It means that the multi-module Maven project that we have created is working as expected. Okay, so one more thing we are missing here. We need to make this Kafka producer Wikimedia module as a jar file. So go to pom.xml of this module and let me minimize this, and here let's give packaging type as a jar. So let's give packaging as a jar for this module and save it, and click on this load Maven changes, and let's again build this multi-module Maven project. So just run Maven clean install, and there we go. It means that the multi-module Maven project that we have created is working as expected. Alright, in next lecture we'll see how to configure Kafka producer. Alright, I will see you in the next lecture. Hi, welcome back. In previous lecture we have created a multi-module Maven project. So basically we have created a parent project. Within that we have created a child project, that is Kafka producer Wikimedia. So this Kafka producer Wikimedia project, it acts as a Kafka producer. Now in this lecture let's go ahead and let's configure Wikimedia producer, and also we'll create a topic within our Spring Boot project. So let's go to IntelliJ IDEA and let's go to this module, that is Kafka producer Wikimedia, and just expand src and then go to resources folder. So within the resources folder we are going to create a application.properties file. So choose file here and just give file name as application.properties, hit enter. So within this application.properties file we are going to configure a producer. So just type the property spring.kafka.producer.bootstrap-servers. Well, here we are going to configure this property because we are going to tell Spring Boot that this is the Kafka broker which is running on port 9092. Alright, so whenever we create a Kafka producer, it will read the real-time stream data from the Wikimedia, and then it will connect to the Kafka broker, and then it will write that data to the Kafka broker. Alright, next let's configure key serializer and value serializer for producer. Well, let's type the property spring.kafka.producer.key serializer and then colon org.apache.kafka.common.serialization.string serializer. So similarly let's configure value serializer class. So let me simply copy this property and paste it over here, and let me change from key to value. Alright, now we have configured key serializer and value serializer classes. Okay, so whenever we develop Kafka producer, so Kafka producer will internally use these serializer classes to serialize the input data. Okay, great. Next we need to create a Kafka topic. Well, go to the main package of this module and right click on the main package, new, and then choose Java class. Let's give class name as Kafka topic config. Alright, and hit enter, and let's annotate this class with @configuration annotation so that Spring will make this class as a Java configuration class. Let's create a bin, Spring bin, within this class. So we are going to basically use Java based configuration to create a Spring bin. So public, and then return type is new topic class from Apache Kafka clients admin package, and then give a method name here as a topic, and let's return object of new topic class. So in order to build this object we are going to use topic builder from Spring package. Okay, Spring framework.kafka.config package, and then it has a name API. So let's use name API, and let's give topic name as Wikimedia underscore recent change, something like this, and then call build method to build the object. Okay, so you can also create the partition by using partitions here, but I want to keep default partitions that is created by Kafka broker. So let's save this and let's annotate this method with @bin annotation. Perfect. Now we have created a Kafka topic. Okay, great. Well, let me recap what we have done in this lecture. We have created application.properties file. Within this file, we have configured key serializer and value serializer classes for the Kafka producer, and we have also mentioned the Kafka broker URL over here. Next, we have created a Kafka topic named Wikimedia_recent change. Alright, great. In next lecture, we will start implementing Wikimedia Kafka producer. Alright, great. I will see you in the next lecture. Hi, welcome back. In this lecture, we will start implementing Wikimedia Kafka producer. So let's head over to the IntelliJ IDEA and let's go to the main package. So look at here, we are in a module, not in a parent project. Okay, so go to main package, right click, new, and then choose class. Let's give class name as Wikimedia changes producer. Okay, so this is the name we are giving to the Kafka producer. So hit enter and let's annotate this class with add service annotation from Spring package. So we are going to make this class as a Spring Bean by using add service annotation. Well, within this class, let's first create a logger instance. So let's have private static final and then logger from self4j and then logger equal to logger factory and then call get logger method and then pass this Wikimedia class name here dot class. Perfect, we have created logger to log the messages. Next, let's go ahead and let's inject Kafka template from Spring Kafka library. So we are going to use Kafka template to send messages to the Kafka broker. So let's first declare a Kafka template and then we use constructor based dependency injection to inject this Kafka template. So let's pass key value as a string type. Okay, and let's say the object name is Kafka template. Now let's create a constructor. Right click, generate constructor, select this variable and then click on OK. Now we have created a constructor for this class. Well, whenever Spring finds a single constructor for a Spring Bean, then Spring will inject this dependency. You don't have to basically add auto-wild annotation over here. Alright, so just ignore this annotation. Spring will automatically inject this dependency whenever it will find a single parameterized constructor in a Spring Bean. Okay, great. Next, let's create a method which will read a real-time Wikimedia stream data. So let's create a method like this. The method is public and the return type is void and the method name something like send a message. Alright, and within this method, let's have a topic name post string topic equal to the topic name we have given Wikimedia underscore recent change. So this is the topic name we have given, right? So let me go to Kafka topic config here and here you can see, well, this is the topic name that we have given to the Kafka topic. Alright, so let's go back to Wikimedia changes producer over here. Now in order to read a real-time Wikimedia stream data, we are going to use event source. So here I am going to write the comment to read real-time stream data from Wikimedia, we use event source. Well, in order to create an event source and read the real-time event data from the Wikimedia, we have to use a couple of libraries. So let's go and let's add a couple of libraries. So go to the browser in a new tab, just type OKHTTP event source maven and hit enter and go ahead and click on this first link and go to 2.5.0 version, and this is the Maven dependency that we are going to use, that is OK HTTP hyphen event source. So this is the dependency that we are going to use to create the event source to read the events from the Wikimedia. So let me copy this dependency, go to IntelliJ IDEA and go to pom.xml of this particular module. So we are not going to add this dependency to the parent project. In fact, we are going to add this dependency to the module. Okay, so go to pom.xml of this module and create a dependency section over here, dependencies, and within these dependencies just paste this dependency. Okay, perfect. Now if you can see the data, this data, real-time stream data from the Wikimedia, so it has a JSON, right? So we also need to use JSON libraries in order to deal with this JSON. So just go ahead and search for JSON Maven, hit enter and go to this first link, okay, and go to this 2.13.2. alright, and just grab this Maven dependency and go to pom.xml again and simply paste it over here. Now we have added JSON core dependency. Let's also add one more JSON dependency, that is data bind dependency. So go ahead and click on this and choose the latest version and just copy this dependency and go to pom.xml again and just paste it over here. Now we have added these three dependencies. Okay, so here this dependency we have added in order to create a event source to read the real-time event data from the Wikimedia, and these two dependencies we have added to deal with the JSON data. Alright, so now if you can see here this icon, so go ahead and click on load Maven changes icon over here. Well, as soon as we loaded Maven changes, we got this error, cannot resolve this dependency. Well, basically this OK HTTP hyphen event source, so this dependency needs a transitive dependency. So let's add a transitive dependency for this dependency. So go to browser, go to this Maven repository and here just type HTTP, OK HTTP, hit enter and go ahead and click on this link. So if you can see the error com.squareup.ok, so this is the dependency we need to add. So go ahead and click on it and just scroll down and click on this 4.9.3. so this is the latest release of this dependency. So go ahead and select this Maven dependency, just copy it, okay, and just right below here paste this dependency and go ahead and click on this Maven changes icon. So this will load this dependency from the internet. Now we have added all the required dependencies to the pom.xml file. Now we are good to write the event source code to read the real-time event data from the Wikimedia. Now let's go back to our producer class, that is Wikimedia changes producer. Now we are good to write a event source code which will read a real-time stream data from the Wikimedia. Well, in order to handle the events, we are going to create a separate class, that is Wikimedia change handler. So let me create a class. So right click on the package, new, and then choose Java class, and let's give class name as Wikimedia changes handler. Perfect. And this handler class will implement event handler, event handler interface. Make sure that you choose event handler interface from com.launchdirectly.event source package. Now we need to override a couple of methods from this interface and we need to provide the implementation. So just mouse over on this class and then click on implement methods and then choose all these methods and click on OK. Alright, now in this class we need to only implement on message method. Okay, so these other methods like on open, on closed, on comment, on error, so these are the methods we are not going to implement because these are the methods that we are not going to use. We are going to only use on message method. Well, whenever there is a new event in a Wikimedia, then this on message method will be triggered and then it will read that event. Okay, now what we'll do, we'll create a constructor for this class. So before that, let's declare Kafka template and just pass key type as a string, value type as a string, and then Kafka template. And also let's declare one string variable. It takes a topic value. Okay, perfect. Now let's create a parameterized constructor. Right click, generate constructor, and select these two variables and then click on OK. Now we have parameterized constructor, and these two parameters we pass whenever we create an instance of this class. Alright, perfect. Now just save it and let's go to onMessage method. So within our onMessage method, we want to basically call the Kafka template. So before that, here I'm going to add a logger, private static final, and then logger. So logger from self4j, and then this should be a logger instance, and then logger factory dot get logger, and then pass the class name Wikimedia changes handler dot class. Perfect. So go to onMessage method over here and just add the logger statement. So logger dot info, and then pass the message, let's say string dot format, and type the message something like event data, something like this, and then placeholder, that is %s, and then pass the message. So let's say message event dot get data. Okay, now we have added a logger statement to log the messages. Now let's go and let's use Kafka template to send the event to the topic. So let's say Kafka template dot call send method. So you can see here there are a lot of overloaded send methods. We are going to call appropriate one. So let's choose second one. It takes a topic. So go ahead and call this second one, and then pass first argument as a topic, second argument as message event dot get data. Okay, perfect. Now we have created Wikimedia changes handler. So this will basically trigger whenever there is a new event in a Wikimedia. So basically, if you can see here, we have implemented onMessage method, right? So whenever there is a new event in a Wikimedia, then this handler will be triggered, and this within this handler method, this onMessage method will be called, and within this onMessage method we have written the logic to send this message to the topic using Kafka template provided send method. Okay, it's pretty simple. Now let's go back to our producer class, that is Wikimedia changes producer. So within this producer we are going to call this Wikimedia changes handler class. Let's create a event handler object. So let's type event handler. Make sure that you choose event handler from com.launchdarkly.event source package, and then this should be a event handler equal to new, and then call the implementation class, that is Wikimedia changes handler, and then pass first parameter as a Kafka template, second parameter as a topic. Perfect. Now we have created an event handler. Next we need to define the event source URL, that is REST API URL. So let me simply copy that URL from here. So this is the REST API URL. It provides real-time Wikimedia stream data, right? So let me copy this link and let me pass here. Perfect. Now we need to pass this URL to the event source. Next we need to create an event source which will basically connect to the source, that is Wikimedia source, and it will read all the event data. So let's create a event source, and make sure that you choose event source from com.launchdarkly.event source package, and then call builder. So first we need to create a builder, event source builder, and then we create a event source object from the event source builder. Next new, and then event source dot builder, and then pass event handler as a first parameter, second parameter as the URI. So just call URI dot create and then pass URL. Perfect. Now we have created event source builder. Now let's create a event source object from this builder. So let's say event source and then event source equal to builder dot build method. Perfect, we have created event source object. Well, if you can see the internal implementation of event handler internally uses executor service to create the threads. Okay, so now what we need to do is we need to start this event source in a separate thread. So just call event source dot start. Okay, perfect. I am going to provide the sleep for 10 minutes. So just call minutes and then call sleep and then 10 minutes. Okay, after 10 minutes this should be stopped. Okay, so let me see what is the error here. So this should handle the exception. Okay, perfect. Now what we have done, basically we have created a Wikimedia changes handler. So this handler will be triggered whenever there is an event in a Wikimedia, and then this event source will basically connect to the source, that is Wikimedia source, and the source URL is this, and then this event source will pull all the real-time stream data from this source, and then it will trigger the respective handler. Okay, and then within a handler we have written a code to send that event to the topic, isn't it? Well, in order to run this Wikimedia changes producer, we need to call send message method, right? So just go to main entry point class of this project. So this is the main entry point class, that is Spring Boot main entry point class. So let's implement command line runner interface. It provides a run method. So this run method will be executed whenever this application gets started. So here what I am going to do is I am going to inject private Wikimedia changes producer, and let's use at a toward annotation. Now we have injected this producer, so just call its send message method, right? So whenever we run this Spring Boot application by using this main entry point class, then this object will be instantiated, and then it will call its method, that is send message method. Now let's go and let's try it. So let's run the Spring Boot application and let's see how this producer works. Well, you can see in the console we haven't started the Kafka broker. If the Kafka broker is not running in a local machine, then you will get this kind of warning messages. So let's go and let's run the Zookeeper service as well as Kafka broker. Well, let me open the terminal and let me start the Zookeeper service as well as Kafka broker service. Well, I am using Mac, so I am going to open the terminal, but if you are using Windows, then make sure that you open the command prompt. So let me slightly maximize it and let me zoom it. Okay, so we have Kafka folder in downloads folder, so let me first go into downloads folder and then Kafka, and then we need to execute the command. So let's say in order to run the Zookeeper, we need to trigger this command, that is bin/zookeeper -server-start.sh, and then we need to pass this properties file. Just hit enter. Now our Zookeeper service is up and running in local machine. Similarly, let's go ahead and let's start Kafka broker service. So in order to do that, just open the new cell, go to cell, new window. If you are using Windows, then make sure that you should open a new command prompt. So let me a little bit maximize it, and then let me slightly zoom it, and let me go into Kafka folder. Perfect, and let me run the command. Well, in order to run the Kafka broker, we need to run this command bin/Kafka server start.sh, and then we need to pass this server.properties file. Alright, so hit enter. Now our Kafka broker is up and running on port 9092. Well, in order to confirm whether the Kafka broker is running or not, you can just see this log. Recorded new controller. From now on will use broker localhost 9092. Once you got this log, then you can sure that your Kafka broker is up and running on port 9092. Alright, now let's go back to our Spring Boot project. Well, let's go and let's rerun the Spring Boot application and let's see how this producer works. So let me start the Spring Boot application, and again it has some error, so let me stop the Spring Boot project and let me check what is the error. So it says cause unexpected error. So what is the error? Let me see. Failed to construct Kafka producer. Well, there should be some issue in Kafka configuration. So let me go to application.properties file and let me check what is missing. So here you can see local host. So this should be local host, right? So there is a typo. So let me save this file. Now let's run the Spring Boot application and let's see how this works. And there we go. You can able to see in a console event data is retrieving from the source. You can able to see the log here, event data. So in a Wikimedia changes handler we have logged this statement, right? Event data followed by the message. It means that the Kafka producer that we have written to retrieve a real-time Wikimedia event data from the Wikimedia is working as expected. You can see a lot of data is retrieving. Okay, so there is basically a huge amount of real-time Wikimedia stream data. Okay, so let me stop this, otherwise this will go infinite. Let me stop the server. Now what we will do, we will verify whether the Kafka producer that we have written has sent a real-time stream data to the Kafka topic or not. So in order to verify that, what we can do is we can trigger some command from the command line and then we can see. Well, basically in next lecture onwards we'll create a Kafka consumer to read a real-time stream data from the Kafka broker, but in order to verify quickly we can check or we can verify from the command line. So go to the terminal and let's open a new cell. And then let me slightly zoom it out and let me go to the Kafka folder, downloads, and then Kafka, and then just have a command that is bin/Kafka console consumer.sh, and then we need to pass the topic name, right? So let me quickly change the topic name for this command. Right now the topic name is Java guides underscore JSON, right? So we have given the topic name is Wikimedia underscore recent change. Okay, hit enter. And now here you can able to see, we can see that the consumer is reading a real-time stream data from the Kafka topic, isn't it? Now let's go ahead and let's run our Spring Boot project and let's see how the Kafka producer will retrieve the real-time stream data from the Wikimedia and how it will write to the Kafka topic, and then we'll see this terminal. So let's go to the Spring Boot project and let's run the Spring Boot project, and you can see the Kafka producer is start reading a real-time stream data from the Wikimedia. And similarly, if you go to terminal, you can see here. Alright, so consumer is reading the events or the real-time stream data from the Kafka topic, isn't it? You can just take a look into the console as well as you can take a look into the terminal. As soon as the Kafka producer will read the real-time stream data from the Wikimedia and it will write to the Kafka topic, then this consumer will read that data from the Kafka topic and it will print here in a terminal, isn't it? So it means that the Kafka producer to read the real-time stream data from the Wikimedia is working as expected. In next section of the lectures, we'll start implementing Kafka consumer to read this data from the Kafka topic, and then we'll see how we can write that data to the MySQL database. Alright, I will see you in a next section of the lectures. Hi, welcome back. In previous couple of lectures, we have seen how to implement a Wikimedia Kafka producer, which will basically read a real-time event stream data from the Wikimedia and it will write to the Kafka broker, right? In next upcoming lectures, we'll see how to implement Kafka consumer, which will consume that data from the Kafka broker and it will write to the MySQL database. Okay. In this lecture, we create a Spring Boot project for Kafka consumer, and then next lecture onwards, we'll start implementing Kafka consumer to consume data from the Kafka broker, and we'll also see how to store that data to the MySQL database. Well, let's head over to the IntelliJ IDEA. Here we have parent project. Within that we have module Kafka producer Wikimedia. So let's create one more module. So right click on the parent project, new, and then choose module, and then tick mark this and then click on next, and then let's give module name as Kafka consumer database, something like this, and then click on finish. So this will create this Kafka consumer database module within this parent project. So as soon as we create a module, it will add one entry in a pom.xml of this parent project. So if you can go to pom.xml of this parent project, you can see one entry will be added in a module section, right? So go ahead and click on this load Maven changes icon over here. Okay, now let's make a necessary changes for this module to make this module as a Spring Boot project. So first of all, go to pom.xml file and let's add a packaging type as a jar and save it and click on this load Maven changes button. Next, let's create a main entry point class for this project. So right click on the Java package and new, and then choose package, and let's give package name as net.javagates.springboot. Hit enter, and within this package we are going to create a Spring Boot main entry point class. So right click on this package, new, and then choose Java class. Let's give class name as Spring Boot consumer application, and then hit enter, and let's make this class as a Spring Boot main entry point class. So in order to do that, let's annotate this class with @Spring Boot application annotation, and then within this class let's create a main method. Alright, and within a main method let's call Spring application dot run method, and then pass Spring Boot consumer application class. Alright, perfect. Now we have created Spring Boot main entry point class. Alright, now this module becomes a Spring Boot project. Okay, now we are good to create a Kafka consumer. So before that, let's run this project and let's verify this setup is correct or not. So in order to do that, go to the Maven here and then click on this execute Maven icon over here, and then here just run Maven clean install command, and there we go. Well, look at here, Spring Boot Kafka real world project is a parent project. Within that we have Kafka producer Wikimedia, Kafka consumer database. So these are the two modules within this parent project, and all these projects are build success. It means the module that just we have created under this parent project is working as expected. Okay, great. In next lecture we'll configure Kafka consumer in application.properties file. Alright, I will see you in the next lecture. Hi, welcome back. In previous lecture we have created a Spring Boot project for Kafka consumer. In this lecture we will configure Kafka consumer in application.properties file. So let's go to IntelliJ IDEA and just expand this Kafka consumer database module. Okay, so make sure that you are in a right project. So go to main, and then within main we have resources folder. Within a resources folder we are going to create application.properties file. So right click on this folder, new, and then choose file, and let's call this file as a application.properties. Hit enter. So within this application properties file we are going to configure Kafka consumer details. So first we need to configure Kafka broker URL, that is Kafka broker address. So just type the property spring.kafka.consumer.bootstrap-servers and then localhost :9092. Well, our Kafka broker is running on port 9092, right? So that is what we have mentioned over here. Next, we need to configure a Kafka brook where the Kafka consumer belongs to. In order to do that, let's have property spring.kafka.consumer. and then group -id, and then let's give group name something unique name, that is my group, something like this. Okay, now we have provided consumer group, okay, where this Kafka consumer basically belongs to. Next, we need to provide the offset. Okay, so in order to do that, let's type the property spring.kafka.consumer.auto offset reset earliest. Okay, we give earliest as the value to this offset. Next, we need to configure deserializer classes, right? So basically we need to configure two deserializer classes, one for key, another for value. So just type the property spring.kafka.consumer.key deserializer and then org.apache.kafka.serialization.string deserializer. Okay, so this is the deserializer class that basically deserialize the key in a message. So let's similarly do it for value. So let me copy this property, paste it over here, and let me change from key to value. Okay, now we have configured deserializer classes for key and value. Well, basically Kafka consumer will use these deserializer classes to deserialize key and value in a message. Alright, great. In next lecture, we'll implement Kafka consumer to read real-time stream data from the Kafka topic. Alright, I will see you in the next lecture. Hi, welcome back. In previous lecture, we have configured Kafka consumer in our application.properties file, right? In this lecture, we'll implement Kafka consumer to consume a data from the Kafka topic. Well, let's head over to the IntelliJ IDEA and go to the main package. So make sure that you are in a right project. We are going to create a Kafka consumer in a Kafka consumer database project. So go to main package over here, right click on it, new, and then choose Java class. Let's give class name as Kafka database consumer, something like this. Hit enter, and let's annotate this class with @service annotation. So this will make this class as a Spring Bean. And then let's go and let's create a logger instance. Let's say private static final logger from self4j, and then variable name, and then logger factory, and then call logger get logger API, and then pass class name, that is Kafka database consumer dot class. Perfect. Now we have created logger instance. Next, create a method. Let's say public void, and let's give method name as consume, and let's annotate this method with @Kafka listener. Well, make sure that you choose Kafka listener annotation from org.springframework.kafka.annotation package. Next, we need to pass topic and group ID to this annotation. So just call topics attribute and then pass the topic name. Well, we have given a topic name as Wikimedia underscore recent change, right? So this is the topic name we have given. Next, we need to also provide the group ID. Well, the group ID that we have given is my group, right? So let's have a group ID over here. So just call group ID attribute and then pass group ID as my group. Okay, perfect. So if you can go to application.properties file, we have given group ID as my group, right? Let's go back to our consumer class, and here you can see for this consume method we need to pass the parameter of type string. So let's say event message. Perfect. Now let's log this message. In order to do that, let's use a logger instance and then use info method and then use string provided format method to format the string dot format, and then say, let's say message received, and then placeholder and then pass event message. Well, here is a typo. This should be event message received, something like this. Perfect. Now we have implemented Kafka consumer to consume a data from this particular Kafka topic. Okay, now let's run this Kafka consumer and let's see how this works. So in order to run this, what we need to do is we need to just run the Spring Boot this project. So go to main entry point class, alright, and just run this project, and let's see how this how this Kafka consumer will read the data from the Kafka topic. And there we go, you can able to see in a console event message received. So this is the log statement that we have written in a Kafka consumer, right? So let me go to Kafka consumer, and here you can see the statement event message received. Okay, and in a console you can see event message received. It means that the Kafka consumer that we have written to consume the data from the Kafka topic is working as expected, and you can see the event data. Now let's go ahead and let's run Kafka producer and Kafka consumer together, and let's see the result. So in order to run the Kafka producer, so go to Kafka producer Wikimedia project, okay, and run the project. So by using this main entry point class, you can run the project. Now the Kafka producer is start reading the real-time stream data from the Wikimedia, right? Now parallelly let's run the Kafka consumer. Well, in order to run the Kafka consumer, go to Kafka consumer database project and go to main entry point class, that is Spring Boot consumer application, and just run this project. And you can see in a console there are two tabs. First tab is Spring Boot producer application, second tab is Spring Boot consumer application, and you can see the logs of Spring Boot consumer application event message received. Okay, so parallelly you can see both Kafka producer and Kafka consumer result here. Well, in case of Kafka producer, you can able to see the log event data followed by the event, and in case of Kafka consumer, you can able to see the log event message received followed by the event. Okay, it means that the Kafka producer and Kafka consumer both are working as expected. Okay, great. In next lecture, what we'll do, we'll configure MySQL database in our consumer project, and we'll see how to save these events into MySQL database. Alright, great. I will see you in the next lecture. Hi, welcome back. In previous lecture, we have implemented Kafka consumer to consume the data from the Kafka topic. Next, we need to store that data into the database, right? For that, in this lecture, we will configure MySQL database in a Spring Boot project so that our Spring Boot application can able to connect to the MySQL database, right? So let's head over to the IntelliJ IDEA and let's go to Kafka consumer database project and go to resources folder. Within the resources folder, we have application.properties file. So within this application.properties file, we are going to configure MySQL details. Well, before that, first we need to create a database. So let's go to MySQL workbench, and here just type the SQL statement create database followed by database name, let's say Wikimedia. So Wikimedia is going to be our database name. Let's fire this SQL statement and refresh the schemas, and there we go, Wikimedia database is created. So once we create a database, next we need to add the required dependencies in our Spring Boot project. So basically we need to add Spring Data JPA dependency as well as MySQL JDBC driver. So in order to get these dependencies, what we can do is we can go to the start.spring.io website, that is Spring Initializer website, and go to the add dependency section over here and just type Spring JPA. So you will get this option like Spring Data JPA. So go ahead and choose this Spring Data JPA. Next we use MySQL JDBC driver, right? So just type MySQL, you will get MySQL driver over here. Just choose it. Now we have these two dependencies. Okay, so whenever you want to connect your Spring Boot application to the MySQL database, then you have to add these two dependencies. All right, so Spring Data JPA by default it uses Hibernate as a JPA provider, and we use Spring Data JPA to simplify the repository layer or a DAO layer. Okay, and we use MySQL driver to connect our Spring Boot application to the database. The database is MySQL database. So go to the explore here option and go to pom.xml and just go ahead and grab these two dependencies. Okay, just copy these two dependencies and go to IntelliJ IDEA and go to pom.xml of kafka-consumer-database project. Okay, so make sure that you are in a right project. So go here in a pom.xml and create the dependency section and just paste these two dependencies. Perfect. And click on this load Maven changes icon over here. Now we have added required dependencies. Okay, now let's go to application.properties file and let's configure MySQL database. Okay, so let me go to resources folder. Within our resources folder we have application.properties file, and within this application.properties file we are going to configure MySQL details. So just type the property spring.data_source.url equal to JDBC. So we are going to configure JDBC URL to connect to the MySQL database, right? So JDBC:MySQL and then localhost. Well, we are connecting our Spring Boot application with a local MySQL database, hence localhost, followed by the port of the MySQL server, that is 3306, followed by database name, that is Wikimedia, and then let's configure database username and password. Just type the property spring.data_source.username equal to root. Well, in my case I have given a database username as root, but make sure that whatever the database username that you have given, you have to mention over here. So similarly, let's configure database password spring.datasource.password equal to MySQL@123. Well, whatever the database password you have given to your database, make sure that you have to give here. After that, we need to configure a couple of Hibernate properties. Well, let's first configure Hibernate dilate. So just type the property spring.jpa.properties.hibernate.dilate equal to org.hibernate.dilate.mysql8 dilate. So make sure that you choose latest dilate. So MySQL 8 is the latest dilate as of now. So this dilate is required to the Hibernate because Hibernate will refer this dilate to create the SQL statement to the respective database vendor. In this case, MySQL is the target database vendor, right? So based on this dilate, Hibernate will basically create the SQL statements. Next, let's configure one more Hibernate property to automatically create the database table. Let's say Spring JPA Hibernate .ddl -auto equal to update. So this will create a database table automatically. Well, we want to also see the Hibernate generated SQL statement in a console, right? For that, let's configure a few more Hibernate properties over here. That is spring.jpa.properties.hibernate show underscore SQL equal to true. So this will basically show the SQL statement that is generated by Hibernate in a console. And this spring.jpa.properties.hibernate.use underscore SQL underscore comments equal to true. So this property will basically print the comment. Next, spring.jpa.properties.hibernate.format underscore SQL equal to true. So this property will basically tells Hibernate that whatever the SQL statement that will print in a console should be well formatted. Alright, so these are the few properties that we have to configure in order to connect our Spring Boot application with the MySQL database. Now let's run the Spring Boot application and let's verify whether our Spring Boot application will be able to connect to the MySQL database or not. So go to main entry point class. So make sure that you are in a right project. So open this Kafka consumer database project and go to main entry point class of this project, that is Spring Boot consumer application, and run this class. And you can see there is no errors in a console. It means we have successfully configured MySQL database in our Spring Boot project. Okay, great. In next lecture, we will write a code to save the data into the MySQL database. Alright, I will see you in the next lecture. Hi, welcome back. In previous lecture, we have configured MySQL database in our Spring Boot project. In this lecture, we will see how to save Wikimedia data into MySQL database. Well, we have already written a Kafka consumer which will consume a data from the Kafka topic. Next, we need to save that data into the MySQL database, right? So in this lecture, let's see how to save that Wikimedia data in a database table. Let's head over to the IntelliJ IDEA and let's quickly create a JP entity to store the records into the database table. Well, go to Kafka consumer database project, go to main package, right click, new, and then choose package, and let's give package name as entity. Hit enter. Within entity package, we are going to create a class. Let's give class name as Wikimedia data, something like this. Hit enter, and let's create a fields like private, long ID, and then private string wiki event data. Alright, so let's keep these two fields. Now let's annotate this class with @entity annotation. So in order to make this class as a JP entity, we have to annotate this class with @entity annotation from JPA. Okay, next let's use @table annotation in order to provide table details. So let's give table name. Let's give table name something like Wikimedia underscore recent change, something like this. Next, let's have a @id annotation to make this field as a primary key. Let's also use @generated value annotation to provide the primary key generation strategy. So let's give identity, and here we need to provide lob annotation because the event data is quite huge, right? So in order to store large data, we can use @lob annotation. Okay, great. Now we need to create a getter setter methods, right? So we have already added a Lombok library. We can leverage Lombok provided annotations to automatically create a getter setter methods. So here I am going to use @getter annotation from Lombok library to create a getters method for these fields, and also let's choose @setter Lombok annotation. Okay, so these two annotation will basically create a getter setter methods for these two private fields. Okay, great. Now what we'll do, we'll create a JP repository, that is Spring Data JP repository for this JP entity. So go to main package, right click, new, and then choose package, and let's give package name as repository. And then within this repository package, we are going to create an interface. Let's call it as Wikimedia data repository. Perfect. And let's extend this interface from JP repository interface and then pass first argument as a entity type, that is Wikimedia data, followed by long as a second argument type. Okay, perfect. Now we have created Spring Data JP repository. So it will basically give crude methods to perform database operations on given entity. Now let's go to Kafka consumer class, that is Kafka database consumer. Here we'll inject Spring Data JP repository and then we'll call respective method to save the event data. So here just declare the Spring Data JPA repository, that is Wikimedia data repository. Let's call it as data repository, and let's use constructor based dependency injection. So let me generate the constructor over here. Okay, we no need to add annotation because this Spring Bean contains only one parameterized constructor. Now we have injected Wikimedia data repository. Okay, now let's go and let's call its save method to save the event message. So here I will create an object of Wikimedia data JP entity, new Wikimedia, and then I am going to set the data, that is event message. Next call data repository dot save method and then pass Wikimedia data. Okay, perfect. Now what we have done, we have injected Wikimedia data repository and then we have called its save method to save this Wikimedia data object. Okay, great. Now let's go ahead and let's run the Spring Boot project and let's see how the data will be stored in a MySQL database. We'll go to main entry point class, that is Spring Boot consumer application. From here just run the Spring Boot project and you can see the consumer Kafka consumer is running. Similarly, let's go ahead and let's run the Kafka producer. So go to Kafka producer class project, that is Kafka producer Wikimedia, and then go to main entry point class, that is Spring Boot producer application, and just run this project. So let me select the Spring Boot producer application over here and just start it. And here you can see two tabs: Spring Boot producer application, Spring Boot consumer application. And Spring Boot producer application, it will basically retrieve the real-time stream data from the Wikimedia, right? And here you can see the logs in the console. And in a Spring Boot consumer application, you can able to see the events are storing in the database. You can see the statements, right? Insert into Wikimedia underscore recent change, and then the value is passing. So let me stop both the instances and we can see the log over here. You can see the insert statement, insert into this table, and this is the data, isn't it? It means that we are successfully storing the Wikimedia data into the database. So let's go to MySQL Workbench and here let's refresh the schemas and go to tables and select rows from the table, and you can able to see Wikimedia event data is successfully stored in this table. Well, let me recap what we have done so far. We have created a multi-module MIME project. Within that, we have created two more projects, one for Kafka producer, another for Kafka consumer. Well, we have created a Kafka producer project to implement Kafka producer to read the real-time stream data from the Wikimedia and write that data to the Kafka topic. And then we have created Kafka consumer project to consume the real-time stream data from the Kafka topic and write that data to the MySQL database. I hope you understood how to use Apache Kafka as a broker to exchange messages between producer and consumer in a Spring Boot project.